Now let us look at the next problem. A lamina is made by removing a small disk of diameter 2r from a bigger disk of uniform mass density and radius 2r, as shown in the figure. The moment of inertia of this lamina about axis passing through O and P is IO and IP, respectively. Both these axes are perpendicular to the plane of the lamina. The ratio of IP by IO to the nearest integer is. Okay. Now in this case, first let us find out what is the moment of inertia about point O by the difference method. Let us say the solid disk is present, then the moment of inertia about the solid disk will be given by half m r square. This is the generic formula. So let us say the mass of this, the smaller one is m, then the mass of the bigger one will be equal to, because the radius is twice, the mass will be equal to 4m. Okay. So if we find out the moment of inertia about point O of the solid disk, it will be given by ICM equal to half 4m and radius is 2r square. Okay, so this becomes 8m r square. Now if we find out the moment of inertia of a disk, okay, about point O, which is kept here, okay, if we find out moment of inertia about point O, then that will be equal to I dash cm will be equal to, we know that from parallel axis theorem, it will be ICM plus mr square will give us I dash O. Moment of inertia about point O is equal to moment of inertia about center of mass plus mr square. So I dash O will be given by 3 by 2 m r square. Okay. So the net moment of inertia at point O will be the subtraction or the difference of the bigger disk center of mass, moment of inertia about the center of mass of the bigger disk, and subtracting it with moment of inertia about point O of the smaller disk. So 8 minus 3 by 2 mr square gives us 13 by 2 m r square. So this becomes our moment of inertia about point O. Now in the same fashion, if we wish to find out moment of inertia about point P for the bigger disk without cavity in the laminae, then moment of inertia about point P of the bigger disk will be given by 3 by 2 m r square, and r square is 2r ka whole square. So the value of this becomes 24 m r square. And if we find out due to the smaller disk from parallel axis theorem, then this value will be given by 1 by 2 m r square plus m x square, where x square is root 5. The distance between center of mass and the new point P is root 5. Okay, this is very simple because this value is this value is r and this value is 2r. So from Pythagoras theorem, this hypotenuse is root 5r. So if we put the value of f m root 5 whole square, we will get 1 plus 5 half plus 5 m r square. This value can be written as 11 by 2 m r square. Now the net moment of inertia at point P will be given by moment of inertia of the bigger disk minus the smaller disk about point P. So this is 24 m r square minus 11 by 2 m r square. So we get 37 by 2 m r square, and we have to find out the ratio of IP by IO. So IP is 37 by 2 m r square whole divided by 13 by 2 m r square. This is 37 by 13, the value of which is roughly nearly equal to 3.